channel. Myself, Ravi Kumar. Please subscribe our channel and share to your friends. In this video, I am discussing about the how to find out the unbalanced load parameters by using Millman's's theorem. The main application of Millman's's theorem is nothing but to analyze three-phase loads. That is, you have to find out what is the phase currents or line currents according to by application of the Millman's theorem. I am considering the circuit here. The main Millman's theorem you can apply to star networks. That is, a symmetrical 440 volts three-phase system is applied to a star connected load with the impedances ZR equal to 10 ohms, ZY equal to J5 ohms, and ZB equal to minus J5 ohms. So, as shown in the figure here, this is the circuit. This is the circuit. There is star to star connection. That is, the supply side is also a star connection, balanced star, and it is applied to the unbalanced star connected load. Then, by applying Millman's theorem, the first step is you find out the what is the voltage difference or voltage between the node points. Here, the star connected O and star connected N node here. That is, we consider the neutral point of supply star is O, and the neutral connection of load connection is nothing but N. Then between the N and O, we have to find out the voltage by using the Millman's theorem. Then after that, we have to find out the line currents or phase currents and also powers also. This is a given circuit in the problem. Then we have to consider the sequence, phase sequence is R, Y, B. Then first of all, based on the given data, we have to write down what are the values given in the problem. That is, the symmetrical supply line voltage is given 440 volts, and the impedance of R phase is given 10 ohms. The impedance of Y phase is J5 ohms, and the impedance of B phase is minus J5 ohms. These are the values given. Then based on that, for the given star connected load, then first of all we have to find out what is the phase voltage. We know in star connected, the relation between phase voltage and line voltage is nothing but VL equal to root 3 VPH. That is, the line voltage equal to root 3 times the phase voltage. From that, the phase voltage VPH equal to VL by root 3. Then we know the value of VL 440 and by root 3. Hence, the phase voltage is 254.03 volts. These are the phase voltages. Then, before going to the Millman's formula, then we have to find out the other phase voltage. Consider VRO, the phase voltage is nothing but the reference voltage, that is 254.03 at an angle 0. Similarly, VYO, that is other phase voltage. We know the given supply is star symmetrical. That means all phase voltages are equal, but the voltages are displaced by 120 degrees each other. That's why the magnitude of all voltages are equal, but the phase angle is different. Okay, one by one, the phase angle will be displaced by 120 degrees between the phase voltages. Then If for measurement Millman's theorem, we require admittance value. That is, we have to find out each admittance between the phases based on the given impedance value. That is, YR equal to 1 by ZR. Then we know 1 by 10, that's why 0.1 at an angle 0. The units of admittance is mhos. Then similarly, admittance of Y phase, that is 1 by ZY, that is 1 by J5. The corresponding J5, that is rectangular form, you can convert into polar form. Hence, the value is 0.2 at an angle minus 90 degrees. And similarly, YB, the admittance of B phase. That is, we know the value of impedance is nothing but reciprocal of the impedance. Okay, from that formula, you have to find out each admittance in each phase. Then ZB value is given minus 1 by J5. Hence, the polar form is 50 at an angle minus 90. Hence, 0.2 minus 90 when goes to the numerator value, then minus angle changes to plus angle. That's why 0.2 at an angle plus 90 degrees. So these are the corresponding admittance value, and already we can find out the corresponding phase voltage also. Then from that, we have to find out, that is from Millman's theorem, for unbalanced system, the formula for Millman's theorem, nothing but here, that is the voltages between two star points V N O. Then the formula is VRO YR plus VYO YY plus VBO YB by total admittance value, that is YR plus YY plus YB. So this is the formula of the Millman's theorem to find out the voltage between the two star points, that is V and O, that is from supply side to the load side. We know O is the star point of the star node point of the supply system, and N is the star node point of the load system. Then we have to find out the voltage difference between the two star node points V and O. Then the formula is nothing but VRO YR plus VYO YY plus VBO YB plus YB by total admittance value YR plus YY plus YB. Then we know all values VRO, VYO, nothing but the phase voltages of the system. We know that values here, that is 254.04 at an angle 0 degrees into admittance value 0.1 at an angle 0 degrees. This is the first multiplication, and second one is the 254.03, not 04, 03 at an angle minus 120 into zero point 0.2 at an angle minus 90 plus 254.03 at an angle minus 240 and the impedance value 0.2 at an angle 90. So these are the numerator values by total admittance value, that is 0.1 at an angle 0 plus zero point 0.2 at an angle 90 plus 0.2 at an angle minus 90. Hence, you can simplify the ratio, then we will get the value. That is, you have to simplify that polar form. Again, you can convert to rectangular form, then take the additions. Again, take the division, then you can convert into the corresponding polar form. Hence, the total voltage is, that is 625.96 at an angle 180 degrees. That is volts. This is the total voltage between the two node points of the star connected system. Then after that, from the Millman's theorem, we find out that voltage. Then we have to find out each voltage. That is voltage across the impedance. We have to find out what is the voltage across impedance. Nothing but the line voltages. That is V or Y. Nothing but V or N. We have star connection. That is V or N. The formula is VRO plus VON. But we have the formula VRO minus VNO. The vectors are reversed here. That's why minus changes to plus. Then we know the value of VRO, that is 254.03 at an angle 0 degrees, minus we know the value of VNO 625.96 at an angle 180 degrees. Then we have to simplify the equation, change our two polar forms. You may convert into equivalent rectangular form. Simplify that. Again, you can convert into the equivalent polar form. Then the total value is 880 volts, 880 at an angle 0 degrees. So that is the value of VRN. In the same manner, we have to find out the other voltage also, that is VYN. VYO minus VNO. Then we know the value of VYO, that is 254.03 at an angle minus 120 degrees, and VNO 625.96 at an angle 180 degrees. Then we have to simplify the value. You will get here 545.29 at an angle 23.79 degrees. That is VYN value. Then by using same format, we have to find out VBN also. That is VBO minus VNO. We know the value of VBO, that is 254.03 at an angle minus 240, minus VNO value 625.96 at an angle 180 degree. Hence, we have to simplify the value. You will get here 545.29 at an angle 23.79 degrees. So that is VBN value. Okay, these are the formulas according to the Millman'S theorem. Then we know in star current system, that is line currents equal to phase currents. That's why you may find out line currents or phase current. Both are equal in star connected system. That is, we have to find out IR. We know the formula, that is VRN by ZR. VRN value is 880 volts at an angle 0 by ZR is 10 at an angle 0. That is, the value is 88 at an angle 0 amperes. That is higher value. In the same manner, you have to find out other line current IY. Then the formula is VYN by ZY. The value of VYN is 545.29 at an angle minus 23.79 by ZY value is 5 at an angle 90 degrees. Then you may simplify the equation. You will get the value is 109.06 minus 113, that is 113.7979 degrees. Okay, that is the value of second line current IY, that is 109.06 at an angle minus 113.79 amperes. Hence, that is in the same format, we have to find out the third line current IB, that is VBN by ZB. What is the value of VBN? That is 545.29 at an angle 23.79 positive angle by 5 at an angle minus 90. We may simplify the value, that is same value 109.06, then positive angle 113.79 degrees, that is amperes. Okay. In this way, by using Millman'S theorem analysis, you may find out the line currents or phase currents. That is, the main formula according to the Millman'S theorem is nothing but you have to find out the voltage difference between the two star connected node points, that is V and O, by using formula here. After that, you have to find out the voltage across each impedance. Then after that, you have to find out the phase currents or line currents. So this is the application of the Millman's theorem to solve the unbalanced star connected load. Please subscribe our channel and share to your friends.